Hi guys, in this video we're going to look at the beginning of sequences and series, and we're going to look at sequences, patterns, rules and formula. Now we've done this in junior cert, so some of this will make sense and some of it's a little bit new. So if we have a look at our diagram here, where we are looking for a rule to tell us the number of squares that we're making in each of these diagrams. So you can see here we have 1 square, then we have 1, 2, 3, 4, 5 squares, and then 1, 2, 3, 4, 5, 6, 7, 8, 9 squares. Okay, and we can call this U1, U2, so this is the first term, the second term, the third term, the first picture, the second picture, the third picture, whatever you want to call it. And you can see here what we have is what's called a recursive formula. When we use a recursive formula, what we're trying to do is we're trying to use the previous value in order to get to the next value. So here we can see this is our first term, that's U1. And we're trying to see, well, how do we get from U1 to U2? So what we're saying is we've got 1 here, we've got 5 here, so it seems like we're adding 4 in order to get there. So if we just have a look here, you can see that UN plus 1, so if we say that that's the second term, because that's obviously 1 greater than the first term, what we're doing is we're taking the previous one, which is this one, and we're adding 4 to it. We'll just check to see if it works again. See, so the next picture is the previous picture plus 4. So this here is the next picture to this picture here. So this one here should be 4 more than this here. And you can see this is 5, 1, 2, 3, 4, 5. And this is 1, 2, 3, 4, 5, 6, 7, 8, 9, as we said before. And that seems to work. So the recursive formula is just using the previous answer in order to help us get the next number in the pattern. Now obviously that's not very good if we want to find, say, the 50th term, because that means that we have to find all the way up to the 49th term, because we need the previous one in order to do that. So we come with the idea of what's called the nth term. Now again, you've seen this in junior cert, so this shouldn't be too much of a stretch for you to come to grips with. And what we have here is the fact that we know that the first one has 1, and we're happy that we can get to the next one by just adding 4. We've already worked that one out. From 1 plus 4 is 5, 5 plus 4 is 9, and then we get 9 plus 4 would be 13, and that's going to carry on indefinitely. So you can see what's happening is it's going up in 4s. I should really put plus 4 there, because these things can go down as well. So plus 4, which means if you think about it, if it's going up in 4s, it's just the same as the 4 times table. So in order to find out the nth term here, what we can say is that T of n is equal to whatever the times table is you're using, you stick it in front. So whatever the difference is, this common difference here, is what you stick in front of your n in order to work it out. So it's going to be 4 in terms of n there. That just means that we're using the 4 times table. Now, if we use the 4 times table, I'm sure you're all happy that 4 times 1 is 4. And that's where the 4 times table starts. But we're not starting at 4 for this particular sequence. We're starting at 1. So what we need to do now is we need to adjust it and say, right, okay, it's the 4 times table. We know it's the 4 times table, but it's not starting at 4, it's starting at 1. So how do I get from 4 by 1, which is 4, down to 1? Hopefully you can see that's what I need to do here, is I need to take away 3. Now we just double check it to make sure it works. So if we put T of 1 in here, so I'll just do that here, we can see T of 1, wherever we see an n, we're going to stick 1. So the first term is 4 by 1, okay, so that there goes for the n into there. And we're going to minus 3, and you can see that there is going to be equal to 4 take away 3, which is 1, which is great. And we know that's the first term, because here if you have a look, we just label this one T1, T2, T3, and T4. And let's just check T2 and see if that works as well. So T2 is equal to 4. My n is now 2 because it's the second term, minus 3. And if you work that out, you get 4 times 2, which is 8. 8 to take away 3, which is 5. Happy days. I'm going to do one more, and we'll finish with this one. So it's 4 times 3 minus 3 is equal to, well, 4 3s are 12. 12 take away 3 is equal to 9. So this appears to work for this rule. Okay, we'll just have a look at a few more examples on the next slide. Okay, so for this example, we've been asked to describe each of the following sequences by a rule in words, and where appropriate, give a recursion formula or a formula for the sequence. Okay, so we've got I here. So obviously you can see here what's happening is that the rule is we're adding 4 to the previous number, yeah? Which means that for the recursion, that's fairly straightforward. What we can say then is that the un plus 1, the next term, is equal to the previous term plus 4. And likewise what we did before, guys, we can see that that is going up. So if we look at t of n here, okay, or u of n, whatever you want to call it, t of n and u of n, you can call it u of n if you wish, we'll call it u of n for this one, is equal to, and you can see here, it's the 4 times table, so it's 4n, okay, and then we're not starting at 4 here, we're going, and we're starting at 2, so we need to take away 2. Okay, so just very, very quickly again, see we're adding 4, adding 4, adding 4, adding 4, so we're saying the next term in the sequence, un plus 1, is equal to the previous term, plus 4, that there is your recursive, and then the other thing we're saying is if we want to write this in terms of a tn or un, it's the same thing. What we're saying is it's the 4 times tables, and we are adjusting it to start at 2, so 4 times n, and we're taking away 2, so we start the 4 times table at 2 instead of 4. Okay, let's look at the second one. The second one, you can see here that to get from 6 to 12 we can add 6, but then if we add 6 that doesn't work because 12 plus 6 is not equal to 24. I'm sure you've already spotted that what we're doing is we are multiplying the previous number by 2, so we're multiplying the previous number by 2, okay, by 2, and hopefully you can see that to write this as a recursive, this is just going to be u of n plus 1 is equal to, well, it's just 2 times the previous one, which is 2, by u of n. The formula t of n is equal to, in this particular one, guys, it's 6 multiplied by 2 to the n minus 1. Okay, and that there is something we'll cover in one of the later slides, or maybe you've noticed that because it's doubling, that what we have is 2 to the power of, we're multiplying everything by 2, and if you put n is equal to 1 here, you get 1 minus 1, which is 0, 2 to the power of 0 is obviously 1, 6 times 1 gives you 6, and then you can keep going through and you'll get the answer. Okay, but we'll come and deal with them later. And we have I, it says 2, 3, 5, 7, 11. Okay, hopefully you notice that these are very, 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 very special numbers in mathematics, and essentially it's just the next prime number. So the prime number, so the rule is write down the next prime number. And there's not much more we can do with that, because that there is the holy grail of maths, and if we could find out what the next prime number was, then we'd make a lot of money.